Hello everybody, here's a little bit of clarification and revision for your mini project. So, first of all, if I am correctly informed, you had 3 different experiments. So in the first experiment, you changed the substrate concentration and measured the rate of your reaction, and this was done without the inhibitor. So what do you get with this? You have your substrate concentration and you get your rate here, and this will allow you to determine Km, Vmax and Vmax over Km. These are the 3 important enzyme parameters. How do you find this? Well, you can either do a Lineweaver-Burk plot, so 1 over V versus 1 over S, and you should get something like that. This point here gives you 1 over Vmax. This gives you Km over Vmax. And this one gives you minus 1 over Km. Or you can also do an Eadie-Hofstee plot, which I prefer. So on an Eadie-Hofstee plot you have here V, and on the x-axis you plot V over S, which you easily calculate here. And what you get is something like that. So this point here gives you Vmax. This point here gives you Vmax over Km. And the gradient of that gives you negative Km. So with this, in this experiment, you basically look at the data and try to figure out the enzyme characteristics, Km, Vmax, and Vmax over Km. In the second experiment, you changed the substrate concentration and measured the rate of your enzyme reaction, and you did that at a fixed inhibitor concentration. So again, you got S, you got V, and what this experiment allows you to do is you can check what kind of inhibitor this is. So you get a Km apparent, you get a Vmax apparent, and you get a Vmax apparent over a Km apparent. And again, you can use a Lineweaver-Burk plot to do that, as I explained before. So 1 over V, 1 over S. And you can determine your different parameters, your apparent parameters from that. And what you probably will get is, so if this was your previous plot without an inhibitor, now with an inhibitor, you might get something like that, plus inhibitor. And this indicates that it has the same Vmax, so same Vmax with and without inhibitor, and this is indicative of a competitive inhibitor. Competitive inhibitor. If you've got an uncompetitive inhibitor, 1 over V versus 1 over S, what you would get, so that's without the inhibitor, and with the inhibitor you get a parallel line, so that's plus inhibitor. And so with this it allows you to determine what kind of inhibitor you have. In the last experiment, what that you did was you changed the inhibitor concentration and you measured your rate, and you did that at a fixed substrate concentration. So what you got was inhibitor, and here is the rate. You started with no inhibitor, and then you had different inhibitor concentrations. Here you got your starting rate, and then you got different V observance. And now what you can do in order to find the Ki is you can plot inhibitor concentration on the x-axis and V minus, so this V0 at no inhibitor, minus V observed divided by V observed. And ideally what you should get is a straight line. Now the gradient of this straight line contains the Ki. So this gradient m equals a factor A over Ki. Now this A can be two different things. If it is a competitive inhibitor, so competitive inhibitor, this A is defined as Km divided by the substrate concentration plus Km. And this Km, this was the Km that you determined in the first step where you didn't have an inhibitor. The S here is this fixed S substrate concentration. So that is if you had a competitive inhibitor. If you had an uncompetitive inhibitor, this A is defined as S divided by substrate concentration plus Km. And again, the Km is the one that you identified in the first step without the inhibitor. And the S, again, is this fixed substrate concentration. So you need all these three experiments that you have done in order to find out what is the Km, what is the Vmax over Km of your enzyme reaction without the inhibitor. Then you check out in the second experiment what kind of inhibitor it is. And the third experiment, where you change the inhibitor concentration, helps you to calculate the dissociation constant of the inhibitor. So I hope this makes sense, and thank you for watching.